Okay, this is a recording to discuss a problem uh, commonly referred to as a trigonometric equation. And what we're basically doing here is we have an equation, it looks like this, and we're trying to solve for x. All right, so the equation obviously is cosine of 4 to square root of 2 over 2. Now, what you need to remember is that this right here, 4x, that's I should have put parentheses here. That's the argument of the function. So it's 4 times x. Give me an x. It's a composition of functions is what we really call this. Give me an x. The first function I hit it with is multiply by 4, and then I hit it with a cosine. So it's cosine of 4 times x. In any event, what we're looking for is we are looking to find out what is x. Well, the cosine function has a period of 2 pi. We therefore start by finding the solution in the interval of 0 to 2 pi, but we recognize that there are additional solutions. After we find that first solution, we recognize that there's going to be an infinite number of solutions because of the fact that the sine, the sine and the cosine, all of the trigonometric functions, they are periodic functions. So once you have one solution, you have a whole family of solutions. You just add the appropriate thing to it to get the additional solutions. Okay, so in this case, we're going to find between 0 and 2 pi, and then we're going to find the additional solutions just by adding the integer multiples of 2 pi. But that's going to be adjusted because this is a composition of functions, and we'll see that in just one second here. Okay, so when we when we do this, when we're adding the integer multiples or something of that sort, what I need you to totally understand is that it's it's because it's a periodic function. So it's kind of like adding the minute hand of a clock revolving. Think of a minute hand of a clock revolving about, okay? Think about that for 1 second. So you have an old-fashioned cuckoo clock or something of that sort, and every 15 minutes, or at 15 minutes after the hour, it chimes. Let's just assume that. Okay, so 15 minutes after the hour, it chimes. One revolution later, it chimes again. One revolution later, it chimes again. One revolution later, it chimes again, and so forth and so forth and so forth. Okay, so every revolution, you hear another chime. Well, the metaphor is that that chime is a solution. So if you have a chime, then one revolution later you have another chime. Well, the same idea. If you have a solution, one revolution later you have a solution again. Okay. So let's go ahead and get working on the solution. Cosine 4x is equal to this. That's what we're told. That is what we assume. That's our given. Okay. Well, what we do then is we say, well, it must be true then that 4x is equal to pi over 4. And if you're like me, you think in degrees more easily. So 4x is equal to pi over 4 will solve this equation. If you take 4x of pi over 4, if you take that pi over 4 and you plug it in right here, you're going to get root 2 over 2. Now you also have a solution of 7 pi over 4 as well, but let's consider that one later. Let's do one at a time. Okay, now where do we get that? Okay, in the back of your textbook, there should be a table of values. You can get it from there, or this is something I got off the internet, and I put it at the end of the solution here. This is the unit circle. You probably have something similar to this in your textbook, I would imagine. And remember, on these coordinates here, on the unit circle, the first coordinate here, that's the cosine, and then the second guy, that's the sine. So it's cosine and sine. So the cosine, we look along here, and where do we find root 2 over 2? Boom, there it is. So pi over 4, or 45 degrees, that if you have pi over 4, cosine of pi over 4 is equal to root 2 over 2. Okay? Here's another one, though. Root 2 over 2, that's the cosine. So that's for this guy. That's for the 315 degrees, or otherwise known as 7 pi over 4. Okay? So remember how you do. You go around like this, boom, there you are at 315. From 315 to here, that's the so-called reference angle. That's 45 degrees, right? Because 45 degrees plus 315 is 360. So that's how much is left. Okay, so 45 degrees and 315. But we're going to consider this first one do this one in detail, and then you can do this one yourself. Okay, so we know that 4x solves this equation, and I'm sorry, 4x equals pi over 4 is one solution. That's one of the solution we're going to get. We're going to use right now. And where do we get this? We get this from a table, or we get it from the unit circle that I just attached, or actually, this is one of the ones we can do we can do by hand. This is a 45. This is 45. This is 45. This is 90 degrees. Well, it's 1 root 2. And then, so the cosine of 45 degrees is 1 over root 2. Cosine is adjacent, SOHCAHTOA, adjacent over hypotenuse. So 1 over root 2, multiply top and bottom by root 2, and you get this. Okay? All right. So as I mentioned before, just like the clock chiming, pi over 4 is not the only solution in this family. There's a whole family of solutions. As this clock hand revolves, we're going to get a chime. As this clock hand revolves, we're going to get a solution. So what does it mean to revolve? It means to add 2 pi. So adding 2 pi gives you a revolution. So pi over 4 is a solution. How about plus 1 times 2 pi? That's a solution. Pi over 4 is a solution. Plus 2 times 2 pi. That's a solution. Keep on going. Pi over 4 plus 3 times 2 pi. That's the solution. So we can write this in a more economical way by saying, well, that's pi over 4 plus n times 2 pi. If I were the king, I would leave it like this. I think this is more clear. However, it is customary in the textbooks to write it like this. It's exactly the same, right? N times 2 pi is the same as 2 times n pi. This is the way you normally will see it, but this is the way I look at it when I'm trying to figure out these problems. Okay, so what have we got? We've got 4x is equal to pi over 4 plus 2 n pi. That's a family of solutions, or a set of solutions. Well, is it Miller time? Is it time to quit? No, because we don't really want 4x. We want x. This is symbol stands for therefore. Therefore, what we do is we take 4x is equal to pi over 4 plus 2n pi. That's what we have right here. We multiply both sides by 1/4. And then what do we get? Finally, pi over 16 plus 1/2 n pi, because 1/4 times 2 is 2 over 4. That's 1/2. Gives you that. Okay, I'm sure you can see that. Now, here's what I want you to do. I want you to take a minute. Let's think about all these solutions and go through this with me. If n is equal to 0, it's very simple, right? N is equal to 0, this term just goes away. So we have x is equal to pi over 16, okay? Or another way of saying that, just because if you're like me, you think in degrees easier, it's going to be 11.5 degrees. So x is equal to pi over 16, or 11.5 degrees, but let's keep it at the in the radians, pi over 16. Is this a solution? Well, what do we mean by a solution? In other words, what we mean by a solution is that if we plug pi over 16 into the original equation, is it true? Well, cosine of 4x is equal to this. Okay, that's what we're given. Let's plug in our solution, or our proposed solution anyway, pi over 16. Plug it in. Okay, is that equal to this? Well, 4 times pi over 16 is 1/4 pi. 1/4 pi is indeed equal to root 2 over 2, because that's what we were given. That's what we were told to assume. So it's true. It's a solution. All right. Well, how about the next one? Maybe we got lucky. How about n equals 1? So here's what we start with. We plug in the 1, okay, for n. We get pi over 16 plus 1/2 pi. So in degrees, it looks like this. So now let's go ahead and plug everything in. 4 times x is 4 times this guy right here. And when we do this, the simplifications, we get 4 times pi over 16 is pi over 4. 4 times 1/2 is 2. Now here's a little note. Pi over 4 plus 2 pi, that's the same exactly as pi over 4, because 2 pi is just one revolution. So using my metaphor of the clock, you have a chime at 15 minutes after, you have one revolution, you have another chime. The same thing is happening here. It's a metaphor, but the same thing is happening here. if you have a solution at pi over 4, or if you have pi over 4 and you add 1 revolution, where are you? Well, you're right back where you started from. Okay, now at the risk of beating a dead horse, let's just take something at random, like 45 degrees. You're at 45 degrees, you add 2 pi. What does that mean? You go around 1 revolution. Where do you end up? Right here. 60 degrees. You add 2 pi. Where do you end up? You end up right where you started. So I hope it's abundantly clear that that when you add 2 pi, you're just giving 1 revolution. You're right back where you started. Therefore, if something is a solution, adding 1 revolution, it's still a solution. Okay, that's the point of this comment. Hold on 1 second. I'm getting screwed up here. I'm having difficulties here. Give me 1 second. Okay, I think this is where we left off. So we have pi over 4 plus 2 pi. That's exactly the same as this right here reduces to pi over 4. Now the word reduces maybe is not exactly the right word. What I'm trying to say there is that this line is equivalent to this. And that's because pi over 4 plus 2 pi is exactly the same as pi over 4 for our purposes. For other purposes, maybe it would not be exactly the same. But for our purposes, if we're looking at angles, that's a true statement. Pi over 4 plus 2 pi is the same as pi over 4. Cosine of pi over 4, boom, root 2 over 2. That's what we know from the tables. That's exactly what we started with, okay? All right, let's try one more, or maybe two more. N is equal to 2, okay? Plug it in. What do you get? You get this, okay? So you have cosine of 4x. 4 times this is 4 times this thing right here. Multiply everything out, okay? Well, 4 pi, what is that? That's 2 revolutions. So 2 revolutions, you're right back where you started from. So you're right back at pi over 4, gives me that, which is exactly what I wanted. One more, n equals 3. So I plug in, for n, I plug in 3, plug that in, it's 3 halves, come down here, I put that in here. Cosine of 4 times this stuff gives me 1/4 pi here. 4 times 3 halves. Well, the 4 and the 2 cancel. That gives me 2. 2 times 3 is 6. So there I am. I'm at 6 pi. Boom. That's 3 revolutions. So you see the pattern here. Every time I do this, I'm going to get something like this. I'm going to get I'm going to get a revolution or 2 revolutions or whatever. Up here, I was at 1 pi, so it's 4 times 1 pi gives me 4 revolutions. So each one of these times, I'm just getting revolutions. So if I get revolutions, I have the same answer as I did before. Okay, so it's very easy by doing 2 or 3 or 4 of these, or do 10 of them. I don't care. You just do as many as you need. You're going to convince yourself that this is a family of solutions. This right here, n is equal to 0, 1, 2, 3. This right here is going to be a family of solutions that we're looking for. Okay, so we're saying that this is a family of solutions, and this is the family of solutions that we got from the one answer, the one solution that we had going back in time here. That's the one where we said that that's where this came from, pi over 4, the 45-degree answer, okay? So pi over 4, that's not the only answer, okay? Let's take a look. Let's go back to this. Cosine 4x is equal to root 2 over 2. If we look at our little table again, our diagram, let me bounce down to there. Okay. The other answer we can get is 7 pi over 4, or 7/4 of a pi. So that's my other answer that I can use. Okay, so I'm out of time. So what I'm going to have to do is do one more video, but the next video will be very short.